Hey, what's up everybody? Chris here from the Protocase team, and for this week we're back on the topic of tolerances. And we're talking about what you need to know in order to understand the basics of stack tolerances, explain their impact on manufacturability, and provide some advice to minimize potential design issues. So, let's get into it. So at Protocase and Protospace MFG, with the power of high-velocity mass customization, we can custom manufacture your parts and enclosures in just 2 to 3 days. We also take pride in getting your parts made as accurately as possible. First, let's quickly revisit the fundamentals of tolerances, a topic that we've been discussing over the past number of weeks. Tolerances represent the allowable variation in dimensions for a part or assembly. They ensure that individual features fit together correctly during assembly and function as intended. However, when multiple tolerances apply to an assembly, these variations can stack together, potentially leading to dimension-related issues. To illustrate this, imagine a sheet metal assembly consisting of 5 panels aligned side by side, each designed to be 0.787 inches or 20 millimeters wide. Due to the tolerance for each panel, the total width may actually range from 3.877 inches to 3.996 inches. This is the result of tolerance stacking. So because of this reason, stack tolerances can significantly impact the manufacturability and performance of sheet metal parts, and when tolerances stack beyond acceptable limits, a bunch of problems may arise, such as parts not fitting together due to improper alignment, and cutouts and bends can become slightly misaligned during the assembly period, both causing delays in manufacturing with unnecessary iterations and therefore an increase of cost. Now, before getting into any design advice, it's important to understand which key factors contribute to stack tolerances in sheet metal. Complex designs. During the design phase, multiple dimensions and tolerances are specified, and when these dimensions interact, their tolerances can compound. Intricate designs with closely spaced features or geometric relationships can be more susceptible to tolerance stacking. Misalignments or deviations in one feature can cascade across the entire design, leading to an increased accumulation of errors once assembled. Material properties and behavior. Sheet metal materials can exhibit variations in thickness, elasticity, and thermal expansion, all of which can influence dimensional accuracy. Now, understanding the importance of a stack tolerance is only the first part. Let's look at some tips that will help you design smarter. Starting with simplifying your design. Where possible, reduce the number of individual parts in your assembly. By consolidating parts, you can minimize the accumulation of tolerances. Establish functional tolerance zones. Focus on your critical dimensions first that directly influence the functionality of your part, and loosen the tolerances for any other less critical areas. Okay, so to conclude, stack tolerances may be a small detail, but they may cause big problems if overlooked for complicated designs. For mechanical engineers designing with sheet metal, understanding and addressing stacked tolerancing is essential for creating manufacturable, cost-effective, and reliable products. If you're looking to optimize your designs with expert input, reach out to our team. They can help you refine your tolerance specifications for your exact project requirements. You can reach out to your account manager by filling out the General Contact Us form on our website. The links will be down in the description below. So I hope you enjoyed this brief introduction of stack tolerances in sheet metal. That's it for this week's Proto Tech Tip, and until next time, take care.